Okay, in this video we're going to be talking about complement, which is another key concept from 10.4. And there's some really good information in your book if you want to use that as a supplement for this video on page 652 and 653 that will kind of has all the same information. But I think hopefully if I talk through it that will help you guys a little bit. This is what a complement is. The complement of an event A consists of all of the outcomes in the sample space that are not in A. And then you denote it A with a little like kind of superscript C, almost looks like an exponent. And you say A complement or the complement of A. Okay. So if you think about probability for a minute, the probability of an event happening is all the ways that that event can happen over all the possible outcomes in the sample space. Well, this is all the ways that that event can't happen, or all the ways that it doesn't happen, or basically the rest of the sample space. So let's look at an example, and this will kind of make more sense. If event A is rolling a 6, what is the complement of A? Okay, so the complement of A would be not rolling a 6. So event A, we're calling rolling a 6. Then the complement of A would be all the options where we don't roll a 6. So we could say not rolling a 6. Now, sorry, I should have mentioned this before, but just from context, we're talking about dice here, right? We're talking about rolling a six-sided number cube. That's what they say in the book. So not rolling a 6. But you could also say, another way to say this is, you could say it's rolling a 1, 2, 3, 4, or 5. Right? Because that's all the ways you can not roll a 6. Okay? So if A is rolling a 6, the complement of A is rolling everything else. Or not rolling a 6, in other words. Okay? Alright, now we also want to find the probability of A and the probability of the complement of A. Okay, so the probability of A is all the ways that you can get a 6, all the ways that you can roll a 6. Well, there's only one way for that to happen. Divide that by all the possibilities, right? There's 6 possibilities, so all the ways to roll a 6, there's one of them, over 6 possibilities, 1, 2, 3, 4, 5, or 6, and there's your probability. Okay? Let's find the probability of the complement. Okay, well, how many ways are there to not roll a 6? There's 1, 2, 3, 4, 5 ways for that to happen, right? You could roll a 1, or you could roll a 2, or you could roll a 3, you could roll a 4, you could roll a 5. So there's 5 different outcomes, or 5 different ways that you could not roll a 6 out of 6 possible outcomes. Okay? And there's a couple things that hopefully you're noticing at this point. The first thing that maybe you should notice is that these guys add up to 1, right? What's 1/6 plus 5/6? It's 6/6, which is 1. Okay, that's an important idea. The other idea is that these two events, A and A complement, are always going to be disjoint or mutually exclusive, right? You can't roll a 6 and not roll a 6 in the same roll. It doesn't work like that. So they have to be disjoint. And they add to 1. So if you think about it, the probability of A plus the probability of the complement of A is always going to be 1. And 1 represents 100%, right? So what are the odds that, or what is the probability that I roll either a 6 or not a 6? Well, that's all the options, right? There's 6, there's 1, 2, 3, 4, or 5. One of those things has to happen. So either I roll a 6 or I don't roll a 6, and there's a 100% probability of that happening. So that's kind of interesting. So this is an important idea here. The probability of an event plus its complement is always going to be 1. Okay? Alright, let's take a look at this other one. So it doesn't have to be A. You can use any letter, right? So we're going to use B just to show that it doesn't have to be the letter A. But if event B is pulling an ace from a deck of 52 playing cards, what is B complement? Okay, so B is pulling an ace. B complement is going to be not pulling an ace, or pulling anything that's not an ace, or pulling a 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, or king. So the event, this is an event, complement of B, is not pulling an ace. Okay, so how many ways are there to, well, sorry, we want to find the probability of B and the probability of B complement. So the probability of B is the number of ways we can pull an ace out of the total number of outcomes. So how many ways are there to pull an ace out of a deck of cards? There's 4, because there's an ace of diamonds, an ace of hearts, an ace of clubs, and an ace of spades. There's 4 aces in there out of 52 cards, right? If we want to simplify, this is going to be 12 out of 13, 1 out of 13. Okay? Okay, let's find the probability of not that happening. Okay? So the probability of B complement, the probability of not pulling an ace. Well, this is kind of interesting because you think to yourself, well, how many ways are there to not pull an ace? You could count them all up, but you could also just think, well, hold on a second. If I do 52 minus 4, I get the other 48 options, right? Because these things have to be disjoint. They have to be mutually exclusive. I can't pull an ace and not pull an ace at the same time. That doesn't make any sense. So the idea here is that they have to add up to 1, right? So total, 52 cards, 4 of them are aces. The rest of the 48 cards are not aces, right? So 48 out of 52 is the probability that I get not an ace. And if you simplify this, you're going to get 12 over 13. Okay, once again, notice these are going to add up to 1. Because either you pull an ace or you don't pull an ace. There's a 100% chance that you're going to pull an ace or not an ace. Because those are the only options in the sample space. So the probability of B plus the probability of B, the complement of B, is equal to 1. Now we used kind of an interesting idea in this one. We kind of actually flipped the script around a little bit. We changed the order of this a little bit to help us out. What we did, and you're going to see this written in a couple different ways. Another way to view this, and again, this doesn't have to be a B, it could be any letter. So what we said was 1 minus the probability of B is going to give us the probability of B complement. Right? That's kind of what we did. Because if you think about it, we said, okay, there's 52 out of 52 cards, right? Minus the 52 cards total, minus the 4 cards that give you an ace, equals the 48 cards that are not an ace. Right? We did it with probabilities, though. So we said, okay, 100%, 52 cards out of 52 cards, all the cards, minus the 4 aces out of the 52 cards is going to equal the 48 that are not aces out of the 52 cards. That's kind of how we thought of this. We did 52 minus 4 to get that 48. Okay? So there's more than one way to write this relationship, and sometimes this one is more helpful. Okay? Now in your book, they write this 3 different ways. So I'm going to write this out so you can have the same kind of thing. They use A's, of course, so probability of A plus the probability of A complement equals 1. That's one way to write it. You can also say, well, the probability of A complement is just 1, 100%, or all of the outcomes, minus the probability of getting A, right? So again, the probability of not pulling an ace is 1 minus the probability of pulling an ace. That's kind of the idea there. You could also write it this way. The probability of an event is always 1 minus the probability of its complement. Right? So you could say 1 minus the probability of not pulling an ace is going to be the probability of pulling an ace. Because they always have to add up to 1. Remember that an event and its complement are going to be always mutually exclusive, which means they can't overlap. Okay. So we use this, these are some what we call counting principles. Counting principle is any like rule or idea that will help you find number of outcomes. So these are just different ways of thinking of the same idea to help you to get an answer that you're looking for. So let's take a look at this one here. What is the probability of rolling a 2 or more? Okay. So this language right here, 2 or more, or something like this, you might see something like this, at least 2. Okay. Sometimes it's easier to find the complement than it is to find the actual event. Because what's probability of rolling a 2 or more? That's the probability of rolling a 2 or a 3 or a 4 or a 5 or a 6. And so you have all these different outcomes to think about. Same thing with at least 2. At least 2 is 2 or 3 or 4 or 5 or 6. Now again, we're talking about dice, so sorry, we switched from dice to cards and back to dice. So hopefully with the context that makes sense. But if we're rolling a number cube or a 6-sided dice, what we could do is we could do something different. Instead of finding this probability, the probability of this event, we can do 1 minus its complement. Okay? So let's actually do it, we're going to do it 2 different ways. Okay, so the probability, if I want the probability of A, why don't I just do 1 minus the probability of its complement? Okay, that might be a little bit easier. So what is the complement of rolling a 2 or more? What's the other outcome? So 2, 3, 4, 5, or 6. The only other outcome is rolling a 1. So the complement of this event, 2 or more, is 1. Okay? So what I could do is I could say 1 minus the probability of rolling a 1. Okay? Well, what's the probability of rolling a 1? It's the number of ways to get a 1, which is 1, out of the number of outcomes in the sample space, which is 6. So this would be 1 minus 1 over 6, which is 5 over 6. So the probability of the event that we want, the probability of rolling a 2 or more, is 5/6. It's 1 minus the probability of its complement. Okay? So the probability of rolling a 2 or more is 1 minus the probability of rolling a 1, which is 5/6. So that's kind of a cool way to do it. You're kind of coming from a back door. Now the other way we could have done it is to just figure out, well, how many different ways are there to roll a 2 or more? Well, that would be the probability of 2, or 3, or 4, or 5, or 6. Since these are disjoint, we don't have to worry about rolling a 2 and a 3 at the same time, because that can't happen. This is the probability of 2 plus the probability of 3 plus the probability of 4 plus the probability of 5 plus the probability of 6. And each one of these, there's one way for this to happen. There's one way out of 6 to roll a 2. There's one way to roll a 3 out of 6 options. There's one way to roll a 4 out of 6 options. So each one of these is 1/6, 1/6, 1/6, 1/6, 1/6. So 1 plus 2, 1/6 plus 1/6 plus 1/6 plus 1/6 plus 1/6, all those together is 5/6, which is what we found anyway. So whether you want to find it this way, the probability of rolling a 2 or more, okay, that's 5 over 6 if we do it the long way. But it's also the same thing as doing 1 minus the probability of rolling a 1. Right? Either way, we're going to get 5/6, whether we do it this way or whether we do it this way. So using these principles here, these counting principles, and understanding what the complement is, will help you to make a strategic choice on which way you want to go. Do you want to do all these ORs, find the probability of all these different possible outcomes and add them all together? Or do you just want to find the probability of the opposite happening and subtract it from 1? Kind of choice is up to you, but sometimes this strategy will be much, much easier.